Hi, here I am trying to walk you through the steps of CRISP DM process in implementing a machine learning model for fraud detection. So, for the first step of opportunity evaluation, we have different steps that we need to evaluate. And the problem identification is currently the organization employees are manually going to the transactions and identifying if it is a fraudulent or if it is a non-fraudulent transactions, and this is causing many delays in the fraudulent transactions and causing loss to the customers, and the customers are losing trust in the organization. So we are going to use ML to build a model and help the organization in identifying the transactions which will in turn benefit the customers and the organization. As we have historic data and we can collect more data as required, this is feasible for building an ML model, and also we can train the model using the historic data. And with the historic data and with the training, we can have the model make predictions on the transactions, whether it is fraud or not, and the employees can take respective actions against the customer accounts. And this model will actually help the employees in identifying the transactions and also help the customers in not losing their data or not losing their assets. The organization is very much keen in implementing this ML model. And coming to next step, we have to do the business understanding of the problem. So we have defined the problem that we want to identify the transactions, and currently they are manually identifying the suspicious activities like such as fake transactions or identity theft across different divisions. And this is what making customers lose their trust in the organization. And to define success, we have set the targets as the outcome target is we have to reduce the fraud loss at least by 60%, and also we have to maintain false positive rate below 10%, because the false positive rate might make employees block legitimate customers, which in turn cause the customers to lose their trust. So the organization doesn't want that to happen. So we have to have the outcome target as outcome target to include the main false positive rate also. And the output metric we have been using have to have the precision greater than 0.8, which means like the positive rates are more and the false positive rates are less. Of course, we have some constraints in implementing this model because of the false positive rate, there is a probability that we might be blocking genuine customers, and this would hurt customers, and this would cause a little loss in revenue also. And also the customer data is PII protected and it is sensitive. We have to be mindful in while building the model and training the model so that the customer data is not exposed. And for training the model, we have different factors that we need to take into consideration, such as we have transaction logs on like how much amount is transacted and what's the location that the transaction has happened, and the customer profile data like what age group has most number of transactions and what income section has more transaction numbers. All these factors we can consider and we can use that for training the model. And the next step is solution validation plan. So solution concept here, the main concept is the model has to classify the transactions as fraudulent or it is non-fraudulent, mainly so that it comes under a classification algorithm. Also, you're going to use label data, so that is why we are going to use supervised classification algorithm. And here I'm trying to use logistic regression to build the model. And the features that we can use is transaction amount, location of the transaction happened, the time of the day, the historical spending patterns of the users, and we we can add more features as we go. And we have, while using logistic regression, we have to set the threshold of the probability to identifying the transaction as a fraudulent or not. Like here we can set the threshold as 0.7, and the probability of anything that is greater than 0.7 can be considered as fraudulent, and less than 0.7 can be considered as non-fraudulent. And the evaluation plan that I have designed for this ML model is, initially after training the model, we can test the model for a decided amount of time in shadow mode on live transactions. So that model will be tested in shadow, and the predictions made by the model will be compared against the real values of the customer data, and then we can calculate the precision score. And the precision score is less than our target score, then we can train the model using the latest labeled data by the employees, and we can repeat the process of training, and then we can do further testing, and we can repeat the process until desired metrics are achieved. This is a solution validation plan that we can implement for the model. And next step of building the ML model is we have to make system design decisions. So whether it is cloud versus edge, or offline versus online learning, or batch versus online prediction. So for this version of the model, I have decided that the model needs to be run on cloud, as the computations need to be performed based on historical data, and it's also easier to monitor and retrain the model. And for online learning or offline learning, the model can be trained offline on a schedule, like a weekly or monthly basis, as fraud patterns keep evolving, because the online learning will be really expensive on the organization in the computation perspective. So we can opt for offline learning, like on a schedule basis. And batch versus online prediction, the model has to make real-time predictions. If there is any latency, and we might miss the chance of preventing fraud. So the main goal is we have to prevent the loss before it even happens. So for that, we have to opt for online prediction, where the predictions are generated in real time, and the employees can work on preventing these losses. And the last step is identifying potential risk in production. So after implementing production, there are some potential risks that model might encounter, and we have to monitor the model to enhance its performance. There is a concept shift. So the fraud patterns keep evolving, because like the fraudulent transactions change from time to time, and how they happen. Like the model needs to be retrained consistently so that it keeps up with the new changes in the fraudulent transactions. And also there is a latency issue. The model might experience any network latency, which will delay the transaction approvals. Like for customers, if there is any latency, the transaction will be on hold, and this will cause delay in transaction approvals for customers. And false positives, if there are increasing false positives predicted by the model, this will increase the risk of legitimate customers being blocked by the employees, which in turn will cause loss in revenue and also loss of trust. And data leakage, as I mentioned, like the customer's data is very sensitive, it is PII, and has to be protected and not exposed during the processing. So these are all the factors that I'm considering in building a model for fraudulent identification and prevention. Thank you.